On the last video, when I was doing 1 to 6 on quantum numbers, I had a problem with the video. I'm going to try to fix it. If not, I'm going to have to record it again. But see if you can understand it without the video, looking at what I'm doing. So that way, we don't lose time. We don't have too much time. If you need an extension on that homework, you can ask for it, and I will consider it. But for now, let's go ahead and work on the next one, and it's orbital energy of order. And let's start. Let's start with the problem R1. And as I said, I will go back to the other one and record it, but I need to move on and start with the next section, with this section. So on number 1, okay, A, let's do letter A, and this is the only one I will ask you for. Letter A. I'll let you know which one are we going to do. And in this one, just letter A. And if we have here on A, what is the maximum number of electrons that can be contained in an atomic orbital C? This one. What is the C here? This would be the D, this would be the S, and this would be the P, one of the orbitals, and this would be 2 orbitals on P. Okay, PX and PY, or PY and PZC, and PXC, and PC, sorry. So here we got 1, 2 electron, 3, and 4. Okay, so this, according to the shape, this would be a D, because it's between the X, Y, and C. And this would be a D. How many electrons can you fit on a D? You can fit 1 and 2 here. Okay, in each one. So it's asking you for contain an atomic orbital. As the word orbital is only can fit in any orbital, can only fit 2. If you have 2 orbital would be all this. Okay? Because this is the orientation of D. Okay, and would be 1 and 2 here. So if we take into account this one too, it would be 4. So 2 electrons in 1 orbital. And would be 4 for the whole figure of the C, for all the C. Now, let's keep on moving. I said, don't do the other section. It's like we're short on time, honestly. So let's go ahead and look for the number 2. The number 2 you're not going to do, okay? Number 2. No, number 2. Okay, and I'm going to write it down here. No, number 2. Let's go with number 3. And 3, let me move it up. And we have here, for 3, we have here 5 electrons the question would be number 3. With the 5 electron in an atom have the quantum numbers given below. Arrange this electron in order of increasing energy. If any two have the same energy, so indicate. So let's go ahead and look at the quantum numbers again. N equals 4, L equals 0, Ms equals 0. And what is the Ms? Would be 1 electron. So this basically would be 1 electron on the 4s orbital. Letter B. If N equal to 3, L equal to 1 would be a P. This would be a 3P. And they said that ML is equal to minus 1. Let's do the P and the L and ML. L would be for a P, ML would be a 1. So what would be the ML for L equal 1? Would be minus 1, 0, plus 1. And it would be, and it says minus 1 L. So you would have only 1 orbital on this subshell. So it's 3p. How about the C? The C is N equal 3, the L is equal 2, and that would be a D. And so the ML would be 0. Again, let's do the ML. Minus 2, minus 1, 0, plus 1, plus 2. So what are they asking for? In letter C, they're asking for the ML0. And that's where the electron would be located. And you have only 1. So the rest of them are going to be identical, C to D. And to save time, you can practice them. But it's the same as what we're doing. So it's just only practice. Again, you can always ask me any question you have through instant message, through Skype. And you would get, if I'm on Skype, that I'm usually there while I'm working on the computer, I'm always there, online. Or you can send me an email through Angel, and I get the question right away if I'm on the computer. I'm checking Angel. So electron configuration. Let's start with the electron configuration. Which of the following valence electron configuration is correct for phosphorus 15? What is wrong with each other? Well, let's do the electron configuration of phosphorus 15. The number of electrons for phosphorus, it would be 15. So we got here 1s, 1, 2. 2p, let me do it on top of the s. Sorry. Let me do the s on one side. That's usually the best way of doing it. 2s, here 2p, here 3s. This is 1, 2, 3 orbitals. 3p. And we'll stop on 3p because 1, 2, 3, 4. This is each electron, each arrow up and down. 5, 1, 2, 3, 4, 5, 6. And I'm sorry, I'm filling it out wrong. 7, 8, 9, 10, 11, 12, 13, 4. No, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 electrons here. Okay, that's the electron configuration of phosphorus. Okay, and we need to fill it out. If we are on the same subshell, we need to fill it out as much as ampere as we can before we go to the energy level. Then we start pairing them. But if we are on the same energy level and the same subshell, we need to fill them out first ampere and then start them to pair, if you remember this. So we got phosphorus 15. Let's compare with this one. What happens here? Is this one correct? No, I don't know if you notice here on this one that the two electrons are going on both in the same direction. You cannot have this. They need to go on they need to be on the opposite direction. Remember, two different spins. Let's go on letter B to see what's wrong or right here. Again, you see it jumped, and not even is one of the exception phosphor, and it jumped from the 3s to the 3p. That is wrong too. How about the 3c? The 1c is gonna be 3s to 3p. Here we go. This seems like the right one. And let's look at the D to see if it's wrong. And again, we are pairing here on the same subshell, so this is wrong. So the right answer, the only correct one, would be this one. And as I explained, just remember to put it on your homework. Why are the other ones wrong? Let's move this question up because we have plenty of space, and I want to save all the space I could on this page. And let's go with number 2. Write the notation for the ground state electron configuration of the following atoms and state whether each atom is paramagnetic or diamagnetic. Diagram the valence electron configuration. You need to do the diagram. I don't want the written short version of the written electron configuration like this. One is two. No, I don't want this. I want the electron diagram, and you'll see. And let's go ahead. I'm going to choose several of them. And basically, I want to choose the most difficult one. Now, what is the concept of diamagnetic and paramagnetic? In diamagnetic, I have all electrons pair. All electrons pair. What happened in diamagnetic? I have at least one electron on pair. At least one on pair electron. I am going to do like a little bit more the complicated or longer. Let's look at tin, Sn, and the number of proton, the atomic number is 50. Okay, this means that it has on the periodic table charge 0, it would have 50 electrons. So let's go ahead and start with the electron configuration. You can do the short one. Let's do first the written notation. What is the noble gas that is before the tin? Is krypton. So it's Kr. You can do that. What I want the diagram is of the valence. And this would be the valence. 5s. This is a 5. S2. Right? 4. D10, you already know that the krypton is already full, so you won't have pair electrons there. And 5p2. Let's write it down because looking at this, 2 is an even number. So you can tell me, well, yeah, there is all of them are pair, so it's diamagnetic, and it's not true. It's going to be paramagnetic, and you'll see why. So we got the krypton here, right? And we got, let's do the diagram. 5, we'll start with the valence, okay? Only 5, S1 and 2, right? Then we go and finish the 4D, and then we go back to 5P. 1, 2, 3, 1, 2, 3, 4, 5. So we got here 5S2, 4D10, and this is the right way to fill the electron. 5, we know it's already full, but 6, 7, 8, 9, and 10. And P, we have 1 and 2. How many ampere electrons we have? 2 ampere. So is it diamagnetic or paramagnetic? It's paramagnetic. And this is what you have to do with all of them. Try to do at least as much as you can to practice. So that way when you get to exams, you're faster also, and you have practice and will avoid a mistake. So for zinc, what is the atomic number? 30. How many electrons? 30. So again, we look at the noble gas before, and it's argon, and then we got the 4s2 3d10. I like to fill it out like this, to write it down like this, 4s2. But when you do the diagram, you have to do it in the order it needs to be done. The 4s first, because it's a lower energy level, as a little bit lower. But then you fill it out from the valence, and it's argon. And then you do the diagram for the 4s, 1, 2, 3d, all are pair, so it's what? Diamagnetic. Let's go and do another one. So if you look at a very long electron configuration, don't get scared, because if you write me down that prior noble gas, it would be okay. The most important thing is to write the diagram for the valence. Let's do letter O. And letter O says silver. And it's 79. And it would be equal, what the noble gas? Xenon. What do I have? Well, I have, let me see, I wish I could open a periodic table here so you would see something. Let's open it in Word. You're going to see a better image here. So you get here, okay, it's not with the line, it doesn't matter for now, but if you got here silver, you would see that you have xenon, right, as the prior noble gas, and then you get the 6s, right, 6xs1, okay, hold on, 2, and then it goes to the F. It completely fills the F. If you look at this star, it means that it goes to the F orbital. Then it goes back. From the F, it goes back to the 5D. Well, remember, we're in the 5D, right? The period is the 5. So energy level is 5s, then it goes to 4f, because it hasn't filled it out, and then it goes to the 5d. The same here, when you get here, this is the 6s, the 7s, then you go here to the 5f, and then you go to the 6D. But for now we're on here on silver, and silver would be 6s2, 4f14, and then you'll get 5D, 1, 2, 3, 4, 5, 6, 7, and 8. But you're going to see what's going to happen, because silver is one of the exceptions. So let me go ahead. This is not a good one. Next time I open a better one. So let me go ahead and write the silver, okay, how it should be. And then we'll see what is the exception and why. And that's why I chose this one. So we have 6s2, right? 4F14 and 5D10. Let's do the diagram. That's why I like the diagram too. Xe is equal to the Xe, would be the prior noble gas, and the valence would be 6s2. Then it goes to all the 4F first. 1, 2, 3, 4, 5, 6, 7. And by the way, the periodic table gives you everything. You have to be able to look at them and be able to know, but still do the diagram. This is up, down, 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 and down. Now let's go to the 5D. 5D would be kind of here. 5D. 1, 2, 3, 4, and 5. And it's, I forgot to put the D here, 5D9. That would be, according to all the principles, that would be, to the upper principle, that would be like this. See, but here you're going to have, if the 6S jumps here, forget about the F. And never there. If the 6S jumps here, then you have a half full. So that's why this is again one of the exceptions. So you're going to have, this is the right electron configuration for silver. And by the way, I'm going to go ahead and change it on top. I'll fill it out when I finish the diagram. And it's going to be 6S1, right? And then we got the 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6, 7. I got one orbital more. And then I'll fix it. And then we've got the 5D, and we will got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let me fix this. And we got one orbital more here. It's 7 orbitals. And this would be 6xs1 and 5d10. If you memorize the exception, that would be perfect. But if you go ahead and do the diagram, as I said, that's why I like it, you would see that this would be the wrong one, because this is the more stable configuration. And you see what is the difference on this one. Well, you still have a paramagnetic because you have ampere here. Well, I haven't finished, sorry for this. This one, you're still going to have an ampere here. On this, no. Let me go ahead and erase all this and show you what is the difference of doing the diagram and what's the difference about the exceptions. Because if I ask you, let's say this is the wrong one, okay? And you have a pair here. Okay. Yeah. To get the full, I'm sorry, with silver is the full, it's close to the full 5d10. And this jumps over here. I'm sorry for this. So, this would be the wrong one. And both of them would be paramagnetic, but this is not the right one. But you would have the electron configuration wrong. So it's paramagnetic. Why? Because you have on the 6S1, you have 1 ampere electron. So it is paramagnetic. Let's look at the other exception. And I did it on purpose because that way you got the half full exception. And it's the letter P, and it would be molybdenate. And it would be 42. And it would be krypton, and it would be 5s1, we're on energy level 5, and 4d5. Again, I feel 5. And let me do the electron configuration, the diagram. This is the electron configuration. It's called the shorthand electron configuration. And again, you already know that it's paramagnetic. You have 1 ampere. But let me do the diagram that I'm going to ask you to do the diagram here and on the exam. And it's 5s, 1, 2, 4d. I'm sorry again. I'm getting a little bit tired. And this would be 5s1, 1, 2, 3, 4, 5. And there we go. I have full electron configuration. I have full orbital. So this would be also paramagnetic. You have to do all the diagrams for each one, but don't do it from the energy level 1. Start after the prior noble gas, after the core. Just do it for the valence. Remember, when you get this is the core electron, the prior noble gas, and this would be the valence. And the valence level would be 5. And this is a little bit, because this is transition metal, so it would be S1, N minus 1 is 4, D5. So paramagnetic. Now let's go ahead and do question number 3. We need to move on. And just practice these ones. Now this is kind of the same. The only thing is that you have to take, my recommendation is do the diagram first and then start taking electron to do the charge. So if you have a lithium, right, +1, do the electron configuration of lithium and then take 1 electron. And the electron configuration of lithium is 1s, 1, 2. You can do also with the noble gas first, but here, you know, the lithium has only 3 electrons. So you will go to the 2s, and if you lose 1 electron, you will get the duet, and it's the helium. It's the same as the helium, and it is called isoelectronic with helium. On this one, let's do E. Let's do oxygen, which is easy, but this is A. And then I'll do a more difficult one with the exception B. Oxygen. Oxygen would be, of course, 8 electron, and it's going to be -2. So we're going to go ahead and do, what is the prior noble gas from the oxygen? Is neon, right? Neon, and then you go on to neon. And it's going to be 2s1, 2, and 2p, 1, 2, 3, 4. There you get the valence of oxygen. What happens if oxygen loses 2 electrons? It would be, gains 2 electrons. Gains 2 electrons. And this wouldn't be the neon. I can't repeat I'm sorry for this, but I can't repeat all the video. So, and I can't cut it and paste it, so just erase it, what you've done. And this is oxygen 8, and this would be, what is the prior noble gas from oxygen? Is helium. You didn't notice that. And what would be the electron configuration after helium? Well, let's start counting. It's the 2s1, right? I'm confused in thinking where is we're going with that, and you'll see it's neon, the final electron configuration of O -2. So it's helium, and it's gonna be 2s2, right? 2p, 1, 2, 3, 1, 2, 3, 4. Again, this is the valence of oxygen, 6. What happened if we add 2 electrons? I should put it on red. 1 and 2, because it's oxygen minus 2. This is what happened with me. I got confused taking out. So I put at the end the electron configuration as the noble gas prior to the oxygen, after the oxygen is dead. And what would be the next noble gas? Neon. And that's the electron configuration of O2 minus. Those are isoelectronic. Let me do another one, okay? When you got a negative charge, you have to add electrons. When you got a positive charge, you have to subtract electrons. And that's about it. So you know that already. Let's go ahead and look. Before we get to the exception, let's look at fluorine. Fluoride is called because it's fluorine minus 1. Right? And it's the letter C. And the letter C, let's do the fluorine. Right? Let me have on handy so I don't. Here it is, the one I have. So let's look at fluorine. What is the prior noble gas? Helium again. That way I can also explain it to you better, just in case I do make a mistake or you don't understand it very well. Anyway, I do recommend you to have the book open, your notebook, and the homework, of course, and a periodic table with you. So that way you can follow me better. So what is the atomic number of fluorine? It's going to be 9, so you have 9 electrons, and they're asking for the fluorine minus 1. Okay, but let's do fluorine 9 with charge 0, and it's going to be the prior noble gas, helium again. Okay, and then we have 2s2, and then the p would be 2p. 1, 2, 3, 4, 5. Now, if we add an electron, okay, it's going to be helium, okay, with the full octet. 2s2, 2p6. And that would be the electron configuration again of neon. So I said, all these are isoelectronic, and that's the purpose of this homework. Let's do I'm just looking which one to do. And let's go ahead and look at the number at letter E. Now we're going to go ahead and do letter E. See, you jumped E because it's calcium. You should be able to lose 2 electrons there and be able to do it. Let's do a transition metal, which is in fact an exception. So to chrome, for chrome plus 3, you're going to have chrome plus 3. Again, let's look at our periodic table, and chrome would be 24, and the previous noble gas is argon. So it's going to be chrome. We're going to do the electron configuration of charge 0, and then the ion plus 3. So chrome, right, argon, and then we'll go to which period? Look at your periodic table, right? And you'll see that it's 4s. Of course, we start with the D's and the first row of the transition metal. 4s, 1, 2, 3d, How many do we have in 3D? 1, 2, 3, and 4. 1, 2, 3, and 4. And this is very important. And you have 1, 2, 3, 4, 5 on the again. Okay, again, this jumps over here, and this is gonna be okay, 4s1 3d5. It's gonna be argon 4s1 3d5 because it's one of the exception half full. So if we are going to lose, let me erase this for a second. And if we are going to lose 3 electrons, the first one we lose is this one. Although it's difficult, but we are losing 2 of each one. So it's 1, 2, and 3. So the electron configuration of the chrome plus 3 would be argon, right? And would be 3d3. Let's do one last one. Would be 4, would be palladium, G. And it would be PD, letter G. And it's going to be electron configuration of charge 0 would be krypton, right? And then we are on and this is not one of the exceptions. We have here 5s2 4d 1 2 3 4 5 6 7 8. Okay, so it would be where am I? It would be 5s2 3d 1 2 3 4 5, and it's 1 2 3 4 5 6 7 8. Not one of the exceptions. And you'll see 1 2 3 4, sorry for this one, 6 7 8. So what happens, this is a little bit drunk, this electron. So what happened is we have, right, a PD. Let's look at the charge at the ion, and we have looking to we have +2, lost 2 electrons. So which one do you think is gonna lose? First is gonna lose. Again, don't forget that it's gonna lose always transition metal, the S first, because although it is at a lower energy level because of the shielding and the repulsions, this one is the outermost shell. So what would be the electron configuration? It's gonna be krypton 3. By the way, I would say that I'm tired and I'll do it another day, but I can't because you need to complete this homework. 1 2 3 4 5 6. 1 2 3 4 5 6 7. And 8. I miss one here. 1 2 3 4 5 6 7 8. It's gonna be 5s2 krypton, that's the PD0, and I'm sorry, its PD0 would be krypton, let me write it again, krypton, right? Let me do it the right way, 4D, and it's krypton, that's 0, that's the 0, okay? And it would be charge 0, and it would be krypton 5s2 4d 1 2 3 4 5 1 2 3 4 5 6 7 and 8. So 5s2 4d 8. Of course, if we lose 2 electrons, again we lose the 5s first, and then we're going to get this electron configuration. I need to put in red this one, and it's going to be 8. And this is the electron configuration. Let's do J, because I want to show you something. Again, I hope my mistakes doesn't confuse you more, because I am tired, okay? So, and it shouldn't, because if you look at the corrections, I can see it much better on a piece of paper. So let's do J, and I want to do J because I want to get into the F. So this is bismuth, and it's going to be atomic number 83. So let's start to do the electron configuration from the periodic table for the charge 0, and then we'll look at the charge of the bismuth, which is asking you for Bi plus 3 or 3 plus. Now let's start. First of all, you're going to look at the prior noble gas, and where are we? We are here, and it's a post-transition metal. So it would have the S, here with the star is the F, then it goes back to the D, right? And then it goes to the P. But which level? It goes prior noble gas would be xenon. Then you go to xenon 1, 2, 3, 4, 5, 6 S2. 6s2. Then I'll do the diagram. Then you go F. You jump to F. But which F you're going to go? Go back to 4. Because you haven't filled 4F. So 4F, and it's completely full, the 4F. Because then you come back here. So it's 4F14. And then you go to the D. And which D? You're going to go to 5D. The D are always going to be, right? This is going to be the period, the S. The F is always going to be N minus 2F. And when you go into the D, D is going to be N minus 1D. What do I mean by that? That when you start the period 6, you first fill the S. Unless it's an exception, you jump the electron. Then, instead of going to the 5D, because you know how to do already that, you go down to the 4F. And then to the 5D you go back, and it would be full because you are on this whole way and to this. So after it's full, this would be 5D10, 5D10, and then you go back to the same one, 6P, and it's 3. 1, 2, and 3. And it's going to be 3. So why don't we do here the electron configuration of the diagram for this one. And I did it on purpose because that way you would know the electron configuration of a post-transition metals and its charge. So again, don't worry about the prior noble gas, the core electron, and it's going to be 6s1, 2, 4f, 1, 2, 3, 4, 5, 6, 7. Oh, I'm going to fill it out. No, let me fill it out the right way, just in case. I don't want to then hear that I confuse you more. 1, 2, 3, 4, 5, 6, 7. So it's 14. Then we go back to the 5D. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is all the valence. And what would be the P? And the reality is that it's you have 6s2, 3p6. But it's a post-transition metal, so we go here back to the 6p, and it should be around here. Okay? Doesn't matter where you put it as long as you put it in a higher energy level. And this would be, after the 6s goes the p, and it's gonna be how many on p? 1, 2, 3. If you lose 3 electron on red, we'll do the charge, and you lose 1, 2, 3. This is the outermost shell. And subshell, the outermost shell is 6, and the subshell is a P. Remember, we always lose that. So what would be the electron configuration of bismuth plus 3 plus, or plus 3 would be xenon, and then S2, 4F14, 5D10, this is 14, 5D10, and no 6P. And finally, I did it without a mistake. Was not writing right. Okay. Okay, let's go with problem number 4. And this is simple. And it's like you complete this is the opposite. If I give you the electron configuration, this problem is asking you what is the element. So if you got here all the ion, okay, on 1s2, 2s2, 2p6, 3s2, 3p6. Why don't we look at this element? Where is it? And let's look at it on the periodic table. 1s2, 2s2, 2p6, 3s, 3p. So we are on the second and the third period, right? And we have 3 electrons on the third period. 1, 2, 3. Of course, we don't have the D. And we'll have 3. 1, 2, 3. So well, it would be here, phosphorus 15. How about this one? This is zirconium. Now we have to complete this and then which electron configuration, say which electron configuration we are. So if we are krypton, and we're looking at the 5, 1, 2, 3, 4, and 5. Krypton would be 5s2, okay? 5s2, right? And we got a D. But what do you think that D has to be? It has to be filled because then we're going to a 5p. So we should be, we are here, krypton, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we go 5 on P. 1, 2, 3, 4, and 5. Let me see if we have 5 on P. Yes. So that would be I'm looking at the 4 on P. I'm looking at the E. So that would be, you see how I am today? It's 1, 2, 3, 4. It would be, tell me. Okay, and that would be, let's look at the number 52. This would be iodine, by the way. That's why I was looking at it, because after that, we got, 1 and 2, 53. So we got 53. Okay, and this, what you need to do is complete it, but even that, we got it, I did it already in the prior problem. Let me show you. Do you see? I did the bismuth, but I did it without a charge first. So here you got it. You just have to fill it out here. Now let's do the letter A, the number of A. And let's look at what are they asking? They have the following ground state electron configuration. You've got to do this one with no problem. And let's show you. And this is the one that I was talking, just giving the electron configuration. You can just figure it out what it is. 2s2, 2p3, 2s2, 1, 2, 3, nitrogen. Okay. Let's look at C. 4s2, 4p6, 5s2. So we are here. 4, 1, 2, 3, 4, 4s2, 1, 2, 3, 4s2. I'm on letter C. 4s2, 4p6, 4s2, 1, 2, 3, 4, 5, 6. They omit the D because they can do that. So don't get confused by that. 1, 2, 3, 4. 4, we are on 4 or 5, sorry. 4s2, 4p6, 5s2. You can put it because it's the prior, if you're on 4, right? 1, 2, 3, 4, and or 5, in this case would be 5s2, right? They can write down 4s2, 4, 1, 2, 3, 4, 5, 6. That's a krypton. You don't need to write the 3D because 3D you should write it prior to the 4. And so we go to 5s2. Where are we? Who has the electron configuration of 5s2? Strontium. Yeah, here it is. Okay, as SR. So you do the same thing with each one. Looking at the periodic table, you shouldn't have a problem. Let's look at the following. Okay, let's look at more of them. Let's look at D now. Okay, D would be 3s2, 3p6, 3d8. They wrote the D, doesn't matter, because they already wrote all the D. Then they go with the 4s. You see how you write first, even if it's a D, you write it before the 4s. Even if the 4s, you fill it up before. And that's the same with this one. The only difference is that they didn't write the 3D. It's the only one that goes prior after the 4s2. So 3s2, 3p6, 3d8, 4s2. 1, 2, 3. 3s2, 3p6, 1, 2, 3, 4, 5, 6, and then we go to the 4. 4s2, right? 1, 2, we got here 4s2, and then we got 8 on the D, on the 3D. 1, 2, 3, 4, 5, 6, 7, 8. Where are we, nickel? Right here. We got 8, and we are on nickel. I am sorry. So letter D would be nickel. How about the other ones? Let's do this one that is long too. A long one. And it's going to be E. And it's going to be 4s2, 4p6, 4d2. What happened here is that the 3D is before the 4s2, 4p6, so we ignore it. But 4D to 5s2, you see before the 5s2 we write the 4D, but it's really a fifth period. 1, 2, 3, 4, 5. 5s2, we have filled the 5s2, and then we go back to 4D2. It is 1, 2, zirconium. Okay, and it's zirconium here. Okay, so you do the same thing for all of them. Let's keep it moving. We're almost done with this homework, and I do hope really it helps you. Any question, please feel free to ask. And this is going to be identify the groups that have the following electron configuration in the valence shell and represent the principal quantum number. This just means which column on the periodic table they have this valence. So looking here, that's why I got the periodic table too. On letter A, what is the NS2? What column? It's the 2A. You see? 2A. So the answer for this one would be 2A. I'm probably going to do all of them, or most of them. What would be the B? NS2, NP2. Where do you have an NS2, NP2? All of them. I don't have to put the D. It's all of them. And S2, NP2 is going to be the 4A, because all of them on this column are going to have this electron configuration on the outermost shell. So this one would be the group 4A. How about the C? The C. Oops, isn't that the octet? What do you think it is? The group 8A, that is the noble gas. How about the D? Oops, we got into transition meta, but remember NS2, N minus 1, D2. So let's look at this, NS2, and then 3D. Let's look at the 3, the first one. And that means that it's for every period. So we 3D2, 1 and 2. We are on this group, on the 4B. And this would be the 4B. And how about the E? On the E, we would be NS2, N minus 1D5. NS2 doesn't matter. Let's choose this one. NS2, right? And then we go with 4D5. 1, 2, 3, 4, 5. So what is it? The 7B. And finally, to end up this video, we do letter C. We do number 7. And this is the electron configuration described in the text are all for normal atoms in the ground state. Of course, an atom may absorb a quantum of energy and promote, we saw it on the last homework, on quantum and Bohr and quantum energy. One or more electron to a higher energy level, it becomes an excited atom. The following configuration, remember what happened when you stop applying energy, it won't go down. That we studied that in electromagnetic radiation and quantum energy. It becomes an excited atom. The following configuration represents excited state. Indicate why this is so. Can we have, let me write down the diagram. Sometimes the diagram becomes so handy. And on letter A, it's 1s2. Then do we have a 2? Hold on. I don't have too much space here, and I need the eraser. Okay. And then we do 1s, 1, 2, 2s. and 2p. What's happening here? Okay, let me double check that I did it right, because 1s2, 2s1, 2p1. Is that right? No, because we have to fill the 2s before the p, unless it's the exceptions on the transition metal. So this is the electron, and that's why we have to fill the subshell before going to the next energy level on the next subshell. Okay, on letter B, neon. Neon with neon. And then we got 3s, I'm going to write it down like that. That's the diagram, 3p2. And then, right, 3d. Can it jump? Can it be there without feeling the P? No, that's why. According to what rule? Upper principle. Okay, just remember that. And then let's go to C. And it's the argon. Okay, you don't need to put me which element it is. 3d10. See how the D, we write it before? 1, 2, 3. 1, 2, 3, 4, 5. And then we have to write it like it should be. 4s1. And then we go to 4p3. And here is 1, 2, 3, 4, 1, 2, 4, 5, 6, 7, 8, 9, and 10. What happens if you have an exception? Remember, when we have the exception, the electron jump here to fill the D. And you can have a 4s1, right? And a 3d. A 4s1. Let's do a 4s1 and a 3d10, because this jump for the exception, and that would be the case, for example, of the copper. Okay, but what happens when it has more electron? This is wrong, because instead of going to the 4p, it should finish this one. Okay, so this is wrong. This has to jump, or this has to fill in first. And what would be the electron configuration of 4s2? And think about it. 3, well, we put the 3d10 first. And then the 4p, how many are we going to have? Instead of having 3, right, like the problem says we're going to have, look at the problem. We only have 1 in S and 3 in P. Before going to the 4P, it needs to fill out this S, and it would be 2. And what is that electron configuration? It's 4s2, 3d10, beryllium. Okay, so this is all for now on this end up. If you cannot understand the video without the audio, the prior video, let me know, please, and I would record it again, or help you out with any questions.